Hello everyone! Today we're going to learn kinematics, one dimension in the air. In other words, we throw objects up or down, not horizontal. This we'll do next lesson. When an object is in the air, we know the acceleration. The acceleration will be always g, which is 10, downwards. We can prove it immediately, because when an object is in the air, the force on it is mg, as we know. And if we apply the second law of Newton, we'll get that mg equals to ma. It means that a equals to g. And the direction is downwards. Now, one confusing thing is, the most confusing part of this subject is when we throw an object up, for example, we know that the velocity, first of all, it goes up, then it changes direction and it goes down. So the velocity changed direction, but the acceleration is always downwards. Okay, so we'll deal with it in a lot of exercises today, but the idea is that the acceleration doesn't change, the velocity changes, the direction even changes, but the acceleration is constant. And one other thing that is very important, and we will deal with it again later, if the acceleration is constant and we throw an object up, for example, and it goes down, we don't need to divide when we analyze it, we don't need to divide it into two parts. We don't need to divide it into first up until it stops and then from here downwards. We can use all this way as one part, and we will show it later on. So I'm writing the kinematic equations. We usually deal with, when we do it in one dimension in the air, instead of x, we use y. So the equations will look like this. Y equals to y0, plus v0, v. This is this, and that, and that. And the last one is that. Sorry. Okay. Let's start solving problems and we'll see how we deal with them. So the first problem is this one. I have a tower. Its height is, for example, 80 meters. So it's the first example. And I throw a ball, let's say, downwards in V initial, 20 meters per second. And I want to know again everything. I want to know when it will hit the ground, what speed it will hit the ground, how long it will take, everything. So what do? Exactly the same as we did when we learned kinematics earlier. We write our 6 variables. But in this case, don't forget, it's very important to ask yourself, or you choose the positive direction. We'll change it every exercise. This exercise, let's say, this is the positive direction, and this is the origin, for example. This is y equals 0, okay? And I define it every time, every exercise. So every vector which is in this direction will be positive. Every vector which is in that direction will be negative. Okay, let's start. Y0 is, y initial is 0 because it started here. Y final, when it reaches the ground, it will be 80, plus 80. Why? Because the numbers increase this way, because this is the positive axis. So it's 80. Acceleration is always g downwards, always. Downwards here is a positive, so our a will be plus 10 g. G is 10. Time we don't know. Velocity 0, initial velocity is 20, always, also downwards. with a positive direction, 20. And I want to find these two. Okay, let's find them. So we'll deal with the third equation, y equals to y0 plus a t squared over 2. Let's put a t equals to 0 plus 20 t plus 10 t squared over 2. So it's 5 2t squared plus 20t minus 80 equals to 0. It's a quadratic equation. I can solve it in my calculator very fast. And if you don't know how to do it, if you have these kinds of calculators, you have mode 5.3, and you just have to put the 5, the 20, and the minus 80. It will give you the two solutions to this problem. One solution is 2.47 sec, and the other is negative, is minus. If it's minus, it doesn't mean anything for us because time is always positive for us. So it's 2.47, sorry. The VT, let's find it, V final. Let's use this equation. Okay, so V final is V0 is 20, A is 10, 247. So V final is 20 plus 10 multiplied 2.47. Obviously, 44.7. Okay. So now I know everything about this object. If I want to draw this graph, velocity over time versus time, let's put the numbers here. We have t0 and t 4.47. The initial velocity was 20. Final velocity was 44.7, and it will be like that. This is the graph. Let's see if we conclude from the graph things that we knew from the other lesson when it was on horizontal dimension. The slope must be the acceleration. I remind you, slope, you draw a triangle and you do the vertical over the horizontal. The vertical here is 24.7. The horizontal here is 4.47. If I do 24.7 divided by 4.47, something is not right here. It didn't come up. It should be 10. Something I'm doing wrong, and I will find it, and I will deal with it. Okay. What is wrong? What is wrong? I'll find it in a minute. Maybe here again. I'll do it again. 5, 20 minus 80. 2.47, it was okay. So mod 1. 2.47 multiplied by 10 plus 20. 44.7 minus 20, it's 24.7. And the time, no, the VT is okay, it was 44.7. And the time was 2.47. I didn't copy it right. But you couldn't have told me because you're sitting at home, you can't tell me what I'm doing wrong. But I found it because I have a way to check myself. Vertical over horizontal. So now 24.7 over 4.2.47 is equals to 10. Equals 10, which is the acceleration. If we calculate the area, it's a trapezoid. Let's calculate it. Sum of bases is 20 plus the height here is the base here is 44.7 divided by 2 multiplied by the height, which is 2.47. Let's see how much is it. 20 plus 44.7 divided by 2 multiply 2.47. Okay, it's around 80. Around 80, which is the distance, and the distance is 80. So now I know it's okay. So I have a way to check myself. Okay, the slope must be the acceleration, the area must be the distance, the displacement. Okay, another exercise. We started off in the left foot. Now we're going to take it much more better, much better. Okay. Okay, another one. Again, let's do something downwards. Okay, so I have this tower, which height, I don't know, okay? And I throw the ball here. Let's say V0 is, I don't know, 10. And when it reaches the ground, the velocity is, let's say, Vt. Why do I write V like that? Vt is 80, okay? Meters per second, meters per second. And I want to know everything again. I want to know the height, I want to know the time, everything. Just for the exercise, now let's choose this way to be positive and this to be the origin, okay? So this is y equals 0. This is the origin. Okay, let's write our data. Y, Vf, V0, V final, T, acceleration. Okay, let's start. I remind you, this direction is negative, this direction is positive. So y0 I don't know because I don't know where it started. Yn I do know, it will finish at the ground. V0 is 10, but it's in the opposite direction, so it's minus 10. V final is also in the opposite direction, so it's minus 80. Time I don't know. A is downwards. The acceleration is always downwards, which is G, which is 10, so it's minus 10. Okay, now I can solve it. Let's start with this equation. We can find the time. So minus 80 equals to minus 10 multiplied by t. So I'll get 70 equals to 10t, t equals to 7 seconds. Let's get the y0 from, let's take the first equation. It doesn't matter which one. V final. So y0 equals to y0 plus v0 was minus 10 minus 80 over 2 multiplied by time, which is 7. So 0 equals to y0 plus, it will be minus, minus 90 multiplied by 7 divided by 2, it's minus 315. So y0 is 315. And y0 means where I started from. So it started from height 315. It finished 0, so the height is 315 meters. If I'm right, 90 over 2 multiplied by 7. Looks okay. Again, I can draw a graph. Let's do again. V over t. If I do it, I have 0 and 7. The velocity started with minus 10, finished with minus 80. This will be the graph. Let's see if it's okay. If I calculate the slope, vertical over horizontal. Vertical is 70 over horizontal, which is 7. 70 divided by 7, it's 10, but it's a minus 10 because the line goes this way, downwards. So it's minus 10, and the acceleration is minus 10. If I calculate the area, again a trapezoid, I'll get 10 plus 80 multiplied by 7 divided by 2. Sum of bases, height divided by 2. It's exactly, look, it's exactly the same calculation. It's 315. But why is the direction, why is the area under the axe, the time axe? Because it went in the opposite direction 315. The displacement is in the opposite direction, and again it's true. It started here and it went in the opposite direction, so it will be minus 315. Okay, so that's our second example. Okay, let's continue. Okay, let's start throwing things up. So now I have a tower which is, doesn't matter, 80 meters, and I take a ball and I throw it V0, let's say 40 meters second. Let's define the origin here and the positive here. So if this is y0, this will be y80, obviously, because the numbers increase this way. But now, again, I emphasize it very, very carefully. Look, listen very carefully. Obviously, we all know that the ball will go, will stop, and will go down. Will go up, and then stop, and go down. If the acceleration changes, we must divide it into two parts, from here to there, and from there to there. But if the acceleration is constant, we don't need to do so. We can use all this thing this way as one part. We don't have to divide it. And the acceleration in this case is always g in that direction constant, which means we don't need to divide it from here to there and from there to there. We can start here and finish there automatically. Depends what we want to know. Let's ask two things. I want to know the H max, in other words, this maximum height, and I want to know the total time until it reaches the ground, to the ground. Okay, total time, t, let's say total. Okay, so let's start with finding the H max. Again, our 6 variables. 0, t, a, t. Okay, so our part is we start here, we finish here, because this was the question. Y0 is 80. Y final, I don't know. V0 is 40 plus because it's in the positive direction. V final, the H max, it will stop because then it goes to the other, it starts falling down. So V final will be 0. A will be this direction, and this is our positive direction, so it will be minus 10. And T I don't know. So let's calculate it. Let's use the... let's find the T first. It doesn't matter which we do first. Vt equals to V0 plus 8t. So V final is 0 equals to 40 minus 10t. T equals to 4. I found the T. And let's calculate the H max with the first equation. This one. It's a third equation. Okay, I wrote the third. So y equals to 80 plus 44 multiplied by 4 minus 10 4 squared over 2. Y equals to, so it's 80 plus 160 minus 5 multiplied by 16, 160 meters. So now I know it will reach the height of 160 from the ground, so it will rise 80 meters in this way. Okay, now let's do the second thing they want us to know. I want to know how long it will take the whole way from here to the ground. And I want even to know what the velocity here. And I want to draw a graph afterwards. Let's do so. So again, I write our 6 variables. One more, t. Okay, this is the idea, I don't have to start from here. I can start from here because the acceleration is constant. I don't need to divide it from here to there and from there to there. From here to there, one part. And you will see it in the graph later on, it will make sense. So, y0 is 80. Y final is 0. It started here, it finishes there. A is minus 10 always, even though it changes direction. Because A minus 10 means that when it goes up in the positive direction, it slows it down, which we know. And when it goes down, it accelerates it in the same acceleration, but in the negative direction. So minus 10 means acceleration. It means slowing down in the positive direction. And it also means accelerating in the opposite direction. So anyway, it's minus 10, it's constant. V0 is plus 40. Why plus? Because it's in the positive direction. V final, I don't know. T, I don't know. Okay, this is what I know. Let's use this equation and find the T. So I'll get 0 equals to 80 plus 40t minus 10t squared over 2. Again, I have a quadratic equation. I use my mode 5-3, so I write minus 5, 40, 80. So one solution is 9.66 sec, and the other solution is negative. I don't care for it. Let's find, so it's 9.66. Let's find the VT. VT, we can use this equation. So VT equals to 40 minus 10 times 9.66. So VT will be 40 minus 10 multiplied by 9.66 minus 56.6. Here, minus 56.6. Why is it okay? Because when it reaches the ground, the velocity will be this direction, downwards, opposite the positive direction, so I expect it to be minus. One more thing I want to see, I want to show you, and we'll see it in the next exercise. The pattern that this ball is doing is symmetrical up until here. Why? Because it takes it 4 seconds to go up, we calculated earlier. It will take it also 4 seconds to go down, and when it reaches there, the velocity will be 40 in the opposite direction. It's a known fact, we'll prove it later in the next exercise. But why do I say it? Because what I expect is if it takes 4 seconds to go up, 4 seconds to go down, which means 8 seconds. So I expect the time to go to the ground will be more than 8 seconds. And it's 9.66, so it's logical. One more thing I expect, if the velocity here is 40 downwards, I expect the velocity in the ground to be more than 40 in the absolute value. So it's at 40 downwards, it must be more than 40, and I got 56, so it's okay. Let's draw the graph and see what we conclude from it. We have the V and the T. V is numbers. We started with 40, we went to 0, and then we went to 56.6. Yes. The time we had 4 and we had 9.66. And the graph will be something like that. It must be straight line because the slope doesn't change. Even though the velocity changed from positive to negative, the acceleration is always negative. Let's see if it's okay. If I calculate the slope from this triangle, I'll get 40 over 4, which is minus 10, because it's going downwards. It's okay. If I calculate the slope from this triangle, for example, if I do 56.6 divided by 56.6 divided by 5.66, it's also minus 10. If I use this triangle, the big triangle, I'll get 96.6 divided by 9.66, which is this vertical over horizontal. I will also get the 10. So it doesn't matter which triangle you use to calculate the slope. Areas, let's see about the areas if they are okay. 40 multiplied by 4 divided by 2, it's 80. Which means that it went up 80 meters. It's exactly what it did. Downwards, I need the calculator, 5.66 is this, multiplied by 56.6 divided by 2, it's around 160. So let's see if it's okay. It went up 80, it went down 160, exactly what it did. Now look why, I want to show you one more thing, why 10 minus, why A equals to minus 10 is logical, even though it changes direction. Because here it's logical, intuitive, because the velocity decreases by 10 every second, from 40, 30, 20, 10, 0. Now mathematically, and we know that it accelerates, but mathematically the velocity is still it still decreases because it's minus 10, minus 20, minus 30, minus 40. So the A is still, minus 10 means that the numbers still go down. But in our imagination, or what we know from the exercise, that instead of minus 10, minus 20, we say to ourselves, the velocity is plus 10, plus 20, just in the opposite direction. So mathematically, still, it's okay that it goes down because the numbers still go down. But again, the meaning we understand. Okay, this was a very important example. One more. Now let's prove that the ball does symmetric pattern or whatever. Let's say this is 50 meters per second, and I want to know everything. That's it. I throw a ball from the ground in the velocity of 50. I want to know how much time it will take it to go up and how much time it will take it all the way to go down. What I expect is that it will be symmetrical. So if it takes it x something to go up, it will take it exactly to go down. So I want to know everything again. I want to know here the h max. I want to know t for the top and t total. I want to know everything. And v below and v final. I want to know everything. When will it reach here? What will be the time to reach here? When will it reach here? What will be the time here? What will be the velocity here? Everything. So let's start again. Let's choose our port. Let's say this is the positive way, and this is the origin. So y0, y, a, t, v0, vt. y0 is 0. Y final, I don't know. A, I want now to calculate the top here. A is minus 10 because it's opposite the positive direction. The positive is here, A is there. Time, I don't know. V0 is 50 plus because it's in the positive direction. V final, when it reaches here, it stops. So V final will be 0. Let's use this equation and we'll get 0 equal to 50 minus 10t, t equals to 5. So it will take it 5 seconds to go up. Let's find the way, the maximum height. Let's use the first equation. So y equals to 0 plus 50 plus 0 over 2 multiplied by 5. So it will be 125. 125 meters. So we know it will take it 5 seconds to reach the top, and the top will be 125 meters. Now let's calculate the time it will take it to reach back to the ground, to go back to the ground, but I don't want to start from here, I want to start from there. Okay, so again, our 6 variables, something is missing, t. y0 is 0. Y final is also 0 because it started here, it finishes there. A is minus 10 even though it changes direction. I don't care because A doesn't say about the velocity, it says about the acceleration. The acceleration is always downwards. V0 was plus 50. V final, I want to prove that it's symmetrical problem, so I want to prove it to be minus 50 in this direction. And time I also want to find, I want to prove it, to prove that the time up is the time down. So let's find them and prove it. Let's use the third equation. Okay, so 0 equals to 0 plus 50t minus 5t squared. 10 over 2 is 5. 0 equals to, let's take out 5t, so I'll get 10 minus t. So t is 0 or 10. Why 0? I don't care for it. We know that in t is equal 0, it was on the ground, but we don't care for this solution. It will take it 10 seconds to reach again the ground. And now we prove that it's symmetrical. Why? Because it took it 5 minutes to go up. Obviously, it will take it 5 seconds to go back down. Altogether, 10 seconds. Let's find the Vt. So, Vt equals to 50 minus 10 multiplied by 10. Minus 50, which again, it's okay because it reaches the ground in the velocity of 50, but in the other direction. If I want to show it in the graph of V against t versus t, it will take 50 and 10 seconds. This will be the graph, and this is 5. It took it 5 seconds to stop and 5 more seconds to go to reach the ground in the velocity of minus 50. If I do slopes again, I'll get always minus 10. It's a straight line. It doesn't matter if you use this triangle or that triangle or this triangle. 50 over 5 is 10 minus. 50 over 5, again, minus 10. 100 over 10 is 10 minus because it goes down. Areas. 50 multiplied by 5 is 125 divided by 2. Triangle. 55 again. So now we see the symmetrical value of this problem. It went up 1.25, it went down 1.25. So obviously we're doing something right. One more. Okay, now that we understand the idea, let's throw two objects, like we did in the end of the lesson, in the kinematic lesson earlier. So let's say I have a tower here, h equals to 180 meters, and I drop a ball, velocity is 0, I just drop it, and from the ground I throw another ball, let's say 100 meters per second. Okay. Let's call this ball A, this ball will be B. I want to know where they are going to meet, when they are going to meet, what will be the velocities, I want to see it on the graph, I want everything. Let's choose this to be the positive direction, let's choose this to be the origin. Okay, so let's do the 6 variables for the A, and let's write the 6 variables for ball B. Okay, ball A, I want to find the meeting point. It started here, we don't know, it started at 180. When it will meet him, where it's going to finish, where it meets him, I don't know. V0 is 0. V final, I don't know. Acceleration will be always 10 downwards. This is the positive, so it's minus 10, even though it increases the speed. We know that its speed increases, but it increases in the opposite direction. This is why it's minus 10. And the idea is, when you write the acceleration, don't look at the balls, look just at the positive direction. If it's there, so the A will be always minus 10. If it's there, the A will be plus 10. Time I don't know, also I don't know when they are going to meet. Y0 is 0. Where they're going to meet, I don't know. V0 is plus 100 because it goes in this direction. V final, I don't know. Acceleration is again minus 10 because this is the positive direction and the acceleration is that way, and I don't even care what happens to this ball. Even when we see later, even if I throw the ball diagonally or horizontally, it doesn't matter. In the y-axis, the acceleration will always be 10 downwards. Okay, time I don't know. Let's use this formula for both of them. So if I use it for A, I'll get y equals to 180 plus nothing minus 5 t squared. This is the position of the A, the ball A, is a function of t. If I know the t, I will know the position. Let's do it here again. Y equals to y0, which is 0, plus v0 is 100t minus 5t squared. Now we know that they are going to meet in the same position, so we can compare them. 100t minus 5t squared equals to 180 minus 5t squared. Okay, so t will be 1.8 seconds. So now we know the t. Let's find the v final. The v final we can use this equation. So v final for A will be v0, which is 0 minus 10. So it's minus 18. Why minus 18 is good? Because the direction is this way, so I expect it to be minus. Let's calculate it here. Now here it's a nice example to see how we can conclude what will happen. There are two things that can happen. Maybe when they meet, it will be in this direction, but maybe it went like that and downwards, and when they meet, it will meet him when it goes down. We'll know it from the sign of the v final. If it will be plus, it meets it when it goes up. If it will be minus, it meets it when it goes down. Let's see. So v final equals to v0, which is 100, minus a, which is 10, multiplied by 1.8. So v final will be 82, right? I'll calculate it anyway. 82. It's positive. Positive means that it met it when it was going up. Okay, now let's draw. I want to know two graphs, okay? Let's draw the v over t. Let's also draw the x, okay, we say y over t. I want to see both of the graphs. V over t. We had velocities 100. We add also minus 18. And the time was 1.8. So, the A, it started from 0 to 18. This is the graph for A. Okay, it started from velocity 0, and in 1.8 seconds, it reaches the velocity of 18, minus 18. The other one started at 100, and it finished at 82. Okay. So this is the graph for B. Okay, let's see a few things which are should be. We can conclude that it's okay. First of all, the slopes. If we do that over that, I'll get 18 over 1.8, which is minus 10. If I do here 18 over 1.8, it's minus 10. It's okay. They must be parallel. Why? Because the slope is the same. Both of the accelerations are minus 10, so they are parallel. If I calculate the area, what I will get the displacement. We didn't find the position. Let's just find the position for a moment. Y equals 2. I want to know where they're going to meet. Let's put it here. 180 minus 5 multiplied by 180 squared. 180 minus 5 multiplied by that is 163.8 meters. So they meet here somewhere. 163.8. This is the meeting point. It goes here, it goes there, this is where they meet. So, if I calculate the area, I expect it to be 163. If I calculate this area, I expect it to be the displacement of A, which is it started from 180. So it's 16.2, something like that. Let's calculate it. It's a trapezoid. 100 plus 82 multiplied by 1.8 divide again. 100 plus 82 multiplied by 1.8 divided by 2, 163.8. If I calculate this triangle, I'll get 18 multiplied by 1.8 divided by 2, 16.2. This is exactly what happened. It went down 16.2, it went up 163.8, and then they met. Let's now do this graph. Let's do it from understanding, not from the equations. From understanding, it means that the slope is the velocity. Now we know if the velocity increases, it smiles. If it decreases, it cries. Let's see. We had 0 and 1.8. Let's start with the A. A started in the velocity of 100, positive velocity, and it finished at the velocity of 82. So the velocity decreases, okay? Decreases. Now the finish point was, what was it? 163.8. So it started here, it finished there, but we know the velocity decreases. So it can't be a straight line. It must be in a cry mode, like something like that. Look at the velocity, the slope. It goes like that, like that, like that, like that. Less and less. The slope here must be 100, and here the slope will be 82. So it goes like that. This is A. Let's do the B. This is, this is B. We started with B. This is B. Now the A did something else. It started at 180 and it finished there. So it started here, finishes there. But what happened to its velocity? Also decreases. Why? Because it started with what's the numbers? With nothing, with 0, and it finished with minus 18. So again, we know that it accelerates in the opposite direction, but the number decreases. So again, it will be something like that, like a cry mode. The velocity here is 0, no slope. Then the slope is minus 1, minus 2, minus 3, minus 4, minus 18. The equation that, this is A, the equation for it is exactly that. 180 minus 5t squared. If you know the high math and you find the derivative will be minus 10t. And if you put t 0, we will get the velocity, which, because we know that derivative is the slope, but the slope changes here. So if we put t equals 0, you will get 0. T equal 1.8, you will get minus 18, which is exactly the slope here. The equation for this one is y equals 100t minus 5t squared, this one. If you find the derivative here, you will get 100 minus 10t. And again, look that it's okay. If you put t equals 0, you will get 100. It means that the velocity here is 100, and we know it's true. And if we put 1.8 here, I'll get 82. And the velocity at 1.8 is, the slope here is 82. So it's also okay, the graph. This is a little higher math. If you don't know it, it doesn't matter. It's important that you understand the physics, the basic physics. Okay. So this is the main idea. There are no more things to show you. Maybe we can do another exercise. Let's see. I showed you really everything about this throwing up and down. Maybe one more. Let's do something. Okay, let's do something extra. So one more. I have a tower. And let's say I have a ball here. I throw it up in the velocity of, it doesn't matter, 40. Let's call this ball A. And I throw another ball here, B, at the velocity of, let's say, I really don't care really. Let's put 60, okay? V0 equals 60 upwards. And let's say that this tower is, again, I don't know, 100 meters. Okay. Similar to that question, but the direction are like that. Yes, I'll show you something very interesting here also. But the question is the same. When they meet, meeting place and the meeting place. Where and when they are going to meet. But when they meet, I want to know if they meet. Maybe they won't meet. Why? Because this one goes up and down. This one goes also up and down. Maybe it will not. When it goes up, it will go down. It will go down before it meets it. Maybe they will meet, but when they meet, I want to know if it catches it when it goes up, when it goes down. I want to know what position and what happens to each ball when they're going to meet. Anyway, I want to know everything. So let's do A, let's do B. Again, let's choose this to be positive, and this is the origin. It's a good choice to do so, but you can also do it opposite, it doesn't matter. Okay, A. So I'm writing the 6 variables, A, T, and here also y0, y, v0, v final, A, time. Okay, A is this one. So y initial is 100 meters. Where are they going? If they meet, I don't know when or where, so I don't know it.